Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello students, welcome back to the TV learning program. I'm Teacher Pasco. Today I'm with Senior 1 students, and as usual we will be learning chemistry. We have discussed a lot in unit number 6, the arrangement of elements in the periodic table. And because we have covered almost everything, today we are going to focus on the assessment to test our level of understanding. Before we go to the questions I have set for today's assessment, I want us to try the exercises we have here for actually it's a correction of the homework we did previously. The question number 1 was asking what a metalloid is. What is a metalloid? Let me hope that you've got enough time to try out these questions so that I'm not supposed to be giving you more time to work on that, but I will go straight with the answers. So what is a metalloid? A metalloid is an element which has properties of both metals and nonmetals. In some cases, you may find it behaving like a metal, and in other cases, you may find it behaving as a nonmetal. Remember, we have seen that in the periodic table. We have metallic elements and non-metallic elements. So between the metallic and the non-metallic elements, there are those elements, a small number of elements, which can exhibit the properties of both metals and non-metals, and those are the ones we call metalloids. Explain how metallic character varies across the period. When we move from the left part of the periodic table to the right side of the periodic table, we move from metals to non-metals. And that shows that metallic character decreases as we move across the period, while the non-metallic character increases. And we have explained that if it varies like that, it is because the ease of losing electrons decreases. As you move across the period, the size decreases, making the electrons experience a stronger nuclear attraction, the attraction from the nucleus, and then it becomes very difficult for the electrons to be lost. Hence, metallic character, which is a measure of how it is easy to lose the electron, decreases, okay? And how does non-metallic character change in a group? We say non-metallic character. Moving from the top to the bottom, the size of an atoms increases, and it becomes easier to lose electrons. So the metallic character increases. And we know that as metallic character increases, non-metallic character decreases. So going down the group, non-metallic character decreases. The non-metallic character, which is the measure of how difficult an atom loses its electrons. So when you go down the group, the difficulty of losing electrons decreases because the size is becoming larger and it is becoming easier for the electrons to be lost. Which one between magnesium and sulfur is more likely to lose electrons? Magnesium and sulfur are in the same period, and being in the same period, and we have seen in this question number 2 how metallic character varies across the period, metallic character which is the ease of losing electrons, then we would expect magnesium to lose electrons more easily than sulfur. Why? Because sulfur is less metallic compared to magnesium. Actually, sulfur is a nonmetal, so it doesn't lose easily. But magnesium, which is on the left part of the periodic table, it loses easily because of its big size. So magnesium loses more easily compared to sulfur. Which one between fluorine and iodine would gain an electron more readily? We know that as you move down the group, the ease of gaining electrons decreases because elements are becoming more metallic. So they tend to lose more than gaining. So fluorine would gain electrons more readily than iodine, iodine which has a larger size and weaker nuclear attraction compared to fluorine. Okay? Now let us start the first part of our exercise. And here we have number 1. That is, name 3 scientists who worked on the classification of elements. 3 scientists who worked on the classification of elements. You remember those scientists? We know, for example, Dobereiner with his triads. We know Newland with the octaves. And we know Mendeleev. Okay? We also know Henry Moseley. So we know many of them. And what criteria is used to arrange the elements in the modern periodic table? In the arrangement of elements in the modern periodic table, we use the increasing atomic number, while in the original periodic table, the one of Mendeleev, Mendeleev used the increasing atomic masses. But in the modern periodic table, we use the increasing atomic numbers. The following table gives the atomic numbers of elements P, Q, R, S, and T. Study it and answer the questions that follow. The letters are not the actual symbols of the elements. Yeah. So we have element P with atomic number 3, Q 6, R with 9, S with 11, and T with 14. Sub-question A, identify the elements that belong to group 1. To find the elements which belong to group 1, the first thing we have to do is to find out to write the electronic configuration. So we start with P. We have P with 3. We have Q with 6. We have another one with 9, and that is R. We have S with 11, and we have T with 14. So the electronic arrangement here is 2, 1, 2, 4, 2, 7, 2, 8, and 1, 2, 8, and 4. How do we, the first question is asking the elements which belong to group 1. Remember, elements belonging to a certain group will always have the number of valence electrons or the number of electrons in the last shell which is equal to the group number. So for the elements which are in group number 1, they should all have 1 electron in the last shell. Which elements have 1 electron in the last shell? It's this one in the third shell, and this one in the third shell. So for sub-question A, the right answer is P and T. These elements belong to group 1. Which elements belong to the same period? To know the number of periods, we need what? We need to know the number of energy levels. Okay? You remember that. The number of energy levels is equal to the period number. So which elements have the same number of energy levels? We have to check this. Here we have two energy levels here. Here we have two energy levels. Here we have two energy levels. And even for S and T, we have three energy levels. So the two sets of elements belonging to the same period are these ones. We have P, Q, and R, and the other set is S and T. So these are the two sets of the elements belonging to the same period. Okay? And we go to question number 3. Give reasons for your answers in A and B above. We have already given the reasons. Okay? I have explained why. All the detailed explanations have been given. And D, categorize the elements above into metals, metalloids, and non-metals. Which elements are metals? Which elements are metalloids? Or which ones are non-metals? The non-metals, let's consider this one. This element is carbon. Let's say P. Which one is P? It's lithium. And for Q, it's carbon. And for R, it's fluorine. And S, it's sodium. And for T, it is silicon. So the elements which are metals are these ones. Lithium is a metal, we know that, and sodium is also a metal. Okay? Metal and metal. Carbon and fluorine, these ones are non-metals. And silicon is a metalloid. You remember the classification of elements into metals, metalloids, and non-metals. Good. We go to the next question. Given the following elements and their atomic numbers as A, which is equal to 3, B, which is equal to 9, C, 12, and D, 16, E, 18, F, find out which of these elements is a halogen. Halogens are in group 7. So which element is in group 7? To work out this, we also need the electronic configuration. So we have A with 3, we have B with 9, we have C with 12, we have D with 16, these are atomic numbers. We have E with 18, we have F with 20, and the atomic number, here it is, sorry, the electronic distribution is 2, 1, 2, 7, here it's 2, 8, and 2, here it is 2, 8, and 6, here it's 2, 8, and 8, 2, 8, 8, and 2. So which one belongs to group 7? It's, of course, the one which will be the halogen. It's B. B is a halogen. Okay? B is a halogen. And which one is a noble gas? A noble gas is the one which has 8 electrons on the last shell, and this is the noble gas. The noble gas, and we have an alkali metal. An alkali metal will have 1 electron on 1 electron. It's this one. So this is an alkali. Alkali metal. And we have here there is P and T for question A. Let's check if there is no mistake. Name three, sorry, it's question number 2. Which elements belong to the same period? And question A, this one, asks the elements that belong to group 1. Elements belonging to group 1, oh, there is a mistake. So here there is S and P. So we have to make a correction. It is S, P, and S. Sorry, this was a mistake, but the right answer is P and S. Good. So we go on. Here we have the alkali metal. The alkali metal is this one with 1 electron in the last shell. And the one which is an alkaline earth metal, those ones of group 2, it's this one, alkaline earth metal. And we are done with the third question. We go to question number 4. The following grid represents the modern periodic table. Okay? We have no elements, but it represents the modern periodic table. Study the grid and answer the questions that follow. Name the general term used to describe elements in the shaded region. This region, here we call them the transition elements. Okay? Transition elements. And sub-question B, sodium, magnesium, chlorine, argon, and potassium have atomic numbers 11, 12, 17, 18, and 19 respectively. Indicate the positions of these elements on the grid. Indicate the positions of these elements on the grid, and quickly we go to number C. I want to read B and C and give you some minutes to think about it before I can give you the answers. You have to try also. And another element Y belongs to group 13 and period 2. Indicate the position of element Y on the grid. So let me give you like 40 seconds, yes, 40 seconds, and you think about the respective positions of these elements, sodium, magnesium, chlorine, argon, and potassium, and you go to sub-question C to identify the position of this Y, which belongs to group 13 and period 2. Just 40 seconds, and I give you the answers. Good. Okay, good. Now we have sodium. Sodium has 11. That is the atomic number. It's very simple. You can count from 1. If you count from 1, here we have 2. Here it's 1 here. We go 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So this is the position of sodium according to the increasing atomic number. This is the position of magnesium, and if we go on, you will find that here it is 13, 14, 15, 16, 17. So this is the position of chlorine, and for 18, that is the position of argon, and down here, it is the position of potassium. Very good. And if we go to question number C, the element Y belongs to group 13. Group 13 or group 3. This is 1, 2, and group 3 or group 13. And it also belongs to period 2. This is the second period. Period 1, period 2. So group 13 and period 2, it's here. So this is the position of element Y, okay? Element Y belongs here. Good. So I think we can go to the next question. And we have the following diagram represents a part of the periodic table with elements A, D, E, F, G, and H. But here, be careful, the letters do not represent the actual symbols of the elements. Now, which of these elements is a noble gas? It's very simple. You know the position of noble gases. It's the last group. So a noble gas is hydrogen. This H. It's not hydrogen. It's the element which is symbolized by H, okay? So H is a noble gas. And which is the most reactive metal? The most reactive metal is, we have metals here. These three elements are metals. But we know that in metals, reactivity increases down the group and decreases across the period. So if it decreases, then fluorine should be more reactive than G. Sorry, this is not fluorine. It's a mistake. It's F, an element F. So F is more reactive than G because reactivity decreases across the period. And F will also be more reactive than D because reactivity increases as you go down the group. So among the three, the most reactive metal is F. And 3, the most reactive nonmetal. The nonmetals we have are 3. We have A, we have E, and we have H. But these ones, the noble gases, we consider them to be unreactive because they have complete outermost shells. So they are considered to be inert, non-reactive. And these ones, the halogens, which are very reactive, we know that in the non-metals, reactivity decreases down the group. So A is more reactive than E. And among the 3, the most reactive nonmetal is A. How many electrons are in the outermost energy level of element E? Element E is in group 17 or group 7. So the number of electrons in the outermost energy level will be 7. Okay? That is 7. That is 7. And here we have the last set of our exercises. 6 elements in the present-day periodic table are arranged in order of, do you remember that? Order of increasing atomic numbers, whereas in Mendeleev table, they were arranged in order of their what? Their what? Try to remember. Their increasing mass numbers. Okay? That is the main difference. B, describe the attempts made by the following scientists to classify elements. De Bruijne and Newlands. De Bruijne used triads, a set of 3 elements which have similar properties, whereby the element between the 2 others has almost the average of the properties of those 2 elements. And Newlands classified elements in octaves, sets of 8 elements. so that the first and the eighth elements could show similar properties. An element V is in period 3 and 17, group 17. Write the electronic structure of V. The electronic structure of V will be, it is said it is in period 3, so it has three shells, 2, 8, and the last, which is corresponding to the group number, is 7. So the electronic configuration is this. 7 shows the group, and these 3 sets shows the period. What is the family name for group 7? It is the halogens. Which of the following statements applies to triads? A triad, members of triad have similar physical properties. Triads have similar chemical properties. The properties of the middle element are the arithmetic mean of the other 2. Elements in a triad definitely belong to one group. So I guess C is the one which is right. The properties of the middle element are the arithmetic mean of the other 2. We know that. It's almost the average. Now let's go to the assignment. Remember, practice makes perfect, so we have to always exercise. That is the reason why, even with the assessment, you have the assignment, more exercises to try. An element has the atomic number 16. Identify the group and the period of the periodic table to which it belongs. Very simple. An element belongs to group 3 and period 4 of the periodic table. Write its electronic arrangement. What do elements in the same period and the same group have in common? You identify the similarity of all elements in a given period and all elements in a given group. And then explain the trend in metallic character down the group and non-metallic character across the period. And lastly, but not the least, of course, how is the knowledge of metallic trends useful to an electrician? How is the knowledge of metallic trends useful to an electrician? Thank you very much for your attention. Thank you very much for your active participation. I hope to see you next time. Stay safe.